All right? So when we look at any exponential growth, we have a starting amount, we have an ending amount, and then t is the time. And time could be number of rolls, number of years, could be a number of things. If you guys want to go back to your seats, that'd be great. Okay, then K is the weirdest of them all. This is the rate of growth. Okay, most of the time you have to find the rate of growth first, and then you can go ahead and calculate whatever they want you to calculate. So we're going to start off with 14 of these mega bunnies, and at the end of year 3, we start at year 0, the end of year 3 we have 44 mega bunnies. How many mega bunnies will there be in year 8? So to do this problem, this is classic exponential growth problem. They're pretty much all the same way. Is you start with an amount, you end with an amount, and you need to find K first. So we're going to start with find K. That's the first step. So we start at 14, we end at 44. And then it's e to the k. How many years did it take to go from 14 to 44? How many? 3. So we start with 14, we end with 44. So the first thing you're going to do is divide. And the reason you want to divide first is that you want to get this by itself. If you get this by itself, you won't run into this 14 times e business that some of you tried to do. And then you just do the secret to logs. Log base e of 44 over 14 is equal to 3k. Could somebody take the natural log of 44 over 14 for me? And then divide by 3. Would you give me a decimal, please? By the way, is that going to be positive or negative? Are the number of bunnies increasing or decreasing? Increasing, so therefore this k should be positive. So whatever this is, somebody give me four decimals. Quick, quick, quick. So there we go. We've got our k. You took the natural log of 44 over 14, 44 over 14 first, took natural log, and then divided by 3. This is positive because this is growing. Since it's growing, that number should, growth rate k should be positive. So we know we did that right. Now we do step 2. Now we find a new n at the end of 8 years. Okay, so n at the end of 8 years is going to be equal to, we started with 14, we have e to the k, now we know what k is, 0.3817, and you multiply by 8. See how you can't find this without k? That's why we did that lab. I wanted you to see how important that k was. So now we just use your calculator. N of the 8th year is 14 e to the, somebody tell me real quick, 8 times 0.3817. It should be around 2 point something. Oh, 3? Okay, I guess it was low there. 3.056. Now take 14. 36. Thank you. E to 14 e to that, and that'll tell you about how many bunnies there'll be by year 8. And what is that equal to? So in calculating 14 e to the 3.0536, that gives me 296.68. Now, if you want to know how many whole bunnies there are, that's 296. If you want to round it up to the next one, it'd be 297. But by that 8th year, we have a total of 296 bunnies. Does that make sense? So we did that in 2 steps. The first step, you started with an amount, you ended with an amount. That gives you the k value, the growth rate. Once we had the growth rate, we were looking for year 8. We plug all those in, N0, K, and T this time, and we found out how many bunnies there were. So that's definitely exponential growth. We can do exponential decay the same way. If you have iodine and you're trying to defeat some cancer, suppose the decay of this model has a half-life of 8 days. So we're going to go n equals n0 e to the k t. Now half-life means I start with 10. How much will I end with? 5. Or I start with 2. How much do I end with? 1, right? You can do any number that you want. It doesn't matter. E to the k times 8 days. So if you do 2 and 1, it's pretty easy, and you'll just get 1/2, right? So then you go, well, that looks like a negative now. Now you solve that. Log base e of 1/2 equals 8 times k. And now we can find out what k is. Natural log of 1/2. And then you divide it by 8. Once you know k, then it says find the function t days later. So it's going to be n equal to our starting amount, e to the k, whatever ln of 1/2 over 8 is, times t. That's my equation. So this is decay. This will be a negative number. Okay, for your assignment, you're going to do this problem with cobalt. This problem here with uranium, always fun, playing with uranium. This problem with money, and this one with bacteria. Those 4. If you have time, this would be a challenger. Okay, and I think, yeah, that's day 1. So go ahead and do those. I can help you get started with number 1.